So in this one we have addition of halogens. The reactant will be alkyne. The reagent can be Br2 or Cl2 or I2. And the thing is, it won't stop at an alkene. So it'll go from an alkyne to an alkane, which just means it'll go from triple bonds to single bonds. And so we'll go from this alkyne, have our Br2. And so what the Br2 does is it will attack both the spots at each side of the triple bond. So you'll have two Brs here and two Brs here. So the actual mechanism is this. So we have our we have our Br bonded to a Br, right? Because that's what we have right here, Br2. So two Brs bonded to each other. Now what ends up happening is that each one of them grabs its own electron. And so when that happens, you form two bromine radicals. Once you have a bromine radical, one of the bromine radicals can, and remember that when you have a triple bond, one of the bonds, it has two electrons, right? Each bond has two electrons. So what this bromine radical can do is attack this radical, so it can form a bond, right? So it'll form a bond, but this, the original electron, right, in this triple bond will stay where it is. So you'll have a radical right there. So then what will happen, and remember that it forms right here because this is less substituted. So the radical can be on a secondary rather than a primary, because radicals follow the same rules as carbocations. They prefer higher levels rather than lower levels. So this prefers secondary rather than a primary. So then now you have a radical right here, and the other bromine, right, because we created two, and so the other bromine will come by and then attack right here. So now you have this. And remember, we're still in solution, so there can be more than one of these. Since we're in a solution of Br2, there can be more than one. So what will end up happening is another bromine radical, right, can attack the now double bond. But remember, this also has two electrons, so it attacks this one, forms a bond, and now you have another radical right here at the secondary. And then another bromine can come and bond with it, and now you have two Brs on either side. And that's the final product. So if you go from this to this, if you wanted a alkyne to go to alkane and completely be surrounded with bromines, this is the best reagent to use. It'd be Br2, or if you wanted the other ones, it'd be Cl2 or I2. And the key thing is that you can't make it stop at alkene. It won't. You can't just stop it at a double bond, right? Because as you can see here, since we're in solution, it'll keep attacking until it's completely single bonds. So I hope that helped, and thanks for watching.